In this video on Visual Studio, we're going to be talking about debugging your code. Before we begin, if your keyboard does not have dedicated function keys, that's the biggest upgrade you can get, is a USB or wireless keyboard with function keys. I have them highlighted on this image here, but these are going to make debugging so much easier than having to hit some extra keys to make that function happen. The first and easiest place to start is how we put breakpoints in the code. If I just click into a location, I can hit F9 and I can set a breakpoint. You can see that it has a red dot here. So when that code executes, it should hit a breakpoint. There's two ways that you can do that. You can run your app, and when you run your app, you can hit that breakpoint, but that's a slow way to do this. Generally, there's a lot of setup involved, and you don't really want to do that very often because hitting the conditions for like a row wins here is a harder setup than you would normally have. So what's usually easier is to have unit tests that can hit your code, and then you can get to your breakpoints that way. Choose the easier way. But if you right click onto a unit test and just run it, it won't hit those breakpoints. Those breakpoints only work when you're basically running the app or you're running your unit test in debug mode. So once you're in debug mode, it'll hit those breakpoints, and then you can step through your code. Actions are up here where you can see F11, F10, and Shift F11. So if you hit F10, that actually steps to the next step, and you can see here it's going to return true. If you hit F11 here, what it actually does is it steps into this function, and then you can hit F10 to step through those steps, which is fine, but you can see here we got stuck in a for loop. So what we actually want to do is there's this green with a line here that you can press on that'll run to that line, so you don't have to keep going through that loop execution, and you can step out of there. The other thing you can do is if I hit F11 into here, we can right click and then do run to cursor. It's the same thing as that green icon if that's easier for you, or this control F10, but that lets you run to your cursor. And if it doesn't hit that, it just falls out to the next breakpoint. The other thing you can do is you can just hit F5 and that'll run through the app, keep going through with normal execution. One thing while you're debugging is if the app acts differently when you have breakpoints in, that generally means that you have some kind of threading race condition where there's two things happening in parallel, but when you had a breakpoint, that means they're always happening in order. The only way you can start debugging that is by getting some more information of what's all going on at once, but we're not going to really cover that here in this video. So one of the other interesting things about when you're debugging is there's windows that tell you more information about what's going on. So down here you can see that there's an autos window and a locals window, and these look almost identical. In the locals you can see that the board has some values in it, and in the autos you can see the same information on that board. So there's really no difference between these autos and locals. This is generally where you can see what's going on with your variables really quickly. So if you have a value that's not on your autos that you want to see, but you don't want to keep looking up every time with some of the other inspect tools, what you can do is go over here to this watch. If you double click on this, you can type in something like current player, and you can let this finish that for you. Then if you hit enter, you can see what that value is. So now you can constantly see what that value is as it steps through. That makes it really easy to see what's going on with those values, but it's not too difficult to add more items down here. So you can have everything in scope in your watch window, and that way you can see what values that you want to see change. So when you have your values in your debugging, every once in a while you want to check the values of something or make sure that value has changed or see what happens when that value changes. You can come over to this intermediate window and you can actually change anything you want. So if you say current player here and it says equal to Y, then the second I hit this, you'll see that this has now orange text saying that's changed. So anywhere that it gets accessed, that value is actually updated. And you can do that for any objects. You can also just call any value here and see what the value is. You can do the same thing for current board. Basically, it's your running context, and any value inside of the app can be checked for values. And here, since I stepped into a different function, you can see that before we had the auto and local of board were the same. Now if you look, there's no auto with board, but the local still exists, and it still has those values set. So that might be one of the reasons why you'd use locals over autos. But otherwise, if it's there, it's not that big of a deal. And you can do the same thing for any of these, but you don't have to use this intermediate window to set values. You can hover over values in here and click in if that's easier, or you could come down here and change one of these values like this one, like that, and it changes there as well. So there's a whole bunch of different ways you can change the values on things, but it makes it a lot easier to do testing if you can just go in and hit a breakpoint and change the value to what you want to test it with, and then see how your code reacts. So if you get into a situation where you need a specific value and you can't force it through either unit test very easily, or you can't force it through running the app, sometimes it's easier just to force the value while it's running and step in. So if I step out of this with Shift F11, let's say we tested this with these board values and we want to do a different one. Rather than rerunning the app, if you right click at this line, if you want to rerun that line, you can do set next statement, and then it'll step up there and let you run through it again. So if you edit values on this board and want to see 2 or 3 different scenarios, you can keep coming back up here, set next statement, and rerun steps. And generally that only works in the function you're in. So if we step down here and are in the column wins function, we're not really able to go back up here, right click, and say set next statement. It won't let us jump to a different function. You would have to hit F11 or Shift F11, step out of that function, then set this one, and it'll let you do it at that point. The last thing I want to draw attention to is just how these call stacks work. The call stack window is down here, and what that does is it tells you what line you're on, and as you step in through your code, you'll see that change. It gives you the function and the signature. The top line is where you're currently at. The next line is what calls into that. And in this case, there's only 3 calls. So this is the call that originally called into everything. And so this is my unit test project. So you can see this is where the player when board was called. And it even has line numbers. But this call stack is helpful sometimes when you can get to your code in multiple different places. You can determine where it's coming from. That gives you the weird scenarios. So the call stack is very useful. There's one other window down here that we haven't talked about yet, and that's this breakpoint window. So if we go into our code and just add a whole bunch of breakpoints, you can see all those breakpoints are there. And if you're running through the code and you want to disable some breakpoints, but you don't want to just come into these and find all the files, you can come over here, and you have a couple different ways that you can disable these. You can just unclick these so that only the breakpoint that you originally want is still there. You don't have to remove it completely. You can just use the ones that you want and select the ones you want back and forth. But the other thing you can do here is you can just select all the breakpoints and just delete all of them to get them all out of your app too. So if you put a whole bunch of breakpoints in, and when you're done debugging, rather than keeping all those breakpoints in to always stop your app, you can just go in and manage those in there as well. The other thing you can do is you can create conditional breakpoints. So if I press F9 here to create a breakpoint, if I right click on the breakpoint, you can go to conditions. And so then whenever this condition is true, I'm just going to set this equal to true for now. So this is a conditional breakpoint that will always hit, but you can set it to, like, if my integer is equal to 5, then now I want to hit this, especially if you're in a loop and you want to get to a certain iteration. This can be really helpful to speed up your debugging so you don't go through your loop 36 times. You can just let it run until it hits that step. So once it's a conditional breakpoint, you can close it here. And you can see that the breakpoint has changed. It's now got this black little dot in it. So it's a red circle with a black dot. If I just run this, it'll always hit because it's still conditioned to always be true. But you can also then edit that breakpoint again. You can take out that condition by canceling it. Or by deleting it. That'll get rid of that breakpoint condition, so then it'll just go back to being a regular breakpoint with just the regular red dot. So hopefully you found those tips helpful.